Alright, so this is the chemistry lesson video for section 12.2, and this is part 2. Now remember, if you haven't fully understood part 1 yet, where we talked about mole ratios, then don't start this video. Go back and watch it again, or email me or something until you understand mole ratio, because everything we learn from this lesson video involves mole ratio. Everything you learn from the 12.3 lesson videos involves mole ratio. Alright, so let's go ahead and get started. So when you're doing stoichiometry problems, you follow 3 steps. Okay, so in the previous video, we learned how to do mole ratio. That can get us from one substance in a chemical reaction to another substance. That's how we bridge the gap, like we move from one thing to another. However, when we're in lab, most of the time we don't work with moles. Like if you've ever looked at a lab handout that I've given you, it doesn't say measure out 3 moles of water. Usually we use things like grams or liters or milliliters or, something like that. So a lot of times step 1 is going to be we've got to convert to moles, because the mole ratio is the step that allows us to go from one substance to another. So if you have grams of hydrogen, your first step is convert the grams to moles. So then you can do a mole ratio to get to another substance. And then again, a lot of times we don't want our answer in moles. We want our answer in, molecules or grams or liters. So step 3 is convert to unit asked for. Now, sometimes you can skip 1 or 2 steps. So for example, yesterday, I say yesterday because I made the lesson video yesterday. In the previous lesson video, we did mole ratio. I gave you moles, so there was no point in converting to moles, and I asked for moles, so there was no point in converting to unit asked for. Okay, so you just need to remember the 3 steps and just use them as needed. But know that if you're going from one substance to another, mole ratio is always required. So, I clicked backwards. So, how do we get to moles, or how do we get to the unit asked for? Well, if you remember back from chapter 10, we have 3 conversion factors for the mole. We have 1 mole is 6.02 times 10 to the 23 representative particles. We use that for atoms, molecules, and ions. We have 1 mole equals molar mass. We use that if we're talking about grams. And we have 1 mole equals 22.4 liters when we're at STP, which is standard temperature and pressure. So remember, just a friendly reminder of how to add up molar mass. You find the elements on the periodic table and add up the masses, multiplying by any subscripts. Alright, so the best way to do one of these is just jump right in. Okay, so first of all, I'm going to go back real quick. Whoop, I went forward. I'm going to go back real quick and write our steps over here for us. So our step 1 is, of course, convert to moles. Step 2 is mole ratio. And step 3 is convert to unit asked for. Now, on my website, or if you're in my class, you got one of these, there is a mole map. If you're having trouble following these 3 steps after the lesson video, try using the mole map. That might help kind of guide you through how to do it, but just know on a test or a quiz you cannot use the mole map, so make sure you get to a point where you can do them without the mole map. Alright, so let's move on. So here's our first one. So it says how many liters of acetylene gas, which I tell you is C2H2. So I'm going to put my question mark liters. Remember, I always like to write my information on my reaction. Sometimes there's going to be a lot to keep up with. So at STP are produced by adding water to 5 grams of CaC2. So we're going from here to here. So notice I don't care about water or calcium hydroxide. The question didn't ask me about those. I just focus on CaC2 and C2H2. That's all I do. Alright, so remember, you know how these work. You start with what you're given. So I'm given 5 grams of CaC2. Alright, so we'll go really slow. Okay, sometimes it takes people a couple of tries to get what I'm doing on this. Alright, so step 1 is to convert to moles. We have grams. So how do we convert grams to moles? Well, remember, our options are 6.02 times 10 to the 23 representative particles molar mass, or 22.4 liters. Okay, so here, I'm just gonna write these over here just so that we can refer to them. So we have Avogadro's number, and that's for atoms, molecules, or ions, just in case you don't remember what represented particles means. 1 mole is molar mass. That is, of course, if we're discussing grams, and 1 mole is 22.4 liters, and that's, of course, if we're discussing volume. So I gave you grams, so which one do you think we're going to use? Well, we're going to use 1 mole equals molar mass. So, of course, for molar mass, that's the one where I'm going to have to add it up. So when you add up CaC2, you're going to get 64 grams in 1 mole. So, how do I know which part goes on bottom? 64 grams or 1 mole? Well, you just follow the golden rule. The golden rule says if grams of CaC2 is on top, grams of CaC2 goes on bottom. How many? Well, what we added up off the periodic table. Calcium is 40, carbon is 12 times 2, which gives you 64. Molar mass always equals 1 mole. So on top, I'm going to put my 1 mole. And so notice all of them are CaC2 right now. We have not switched over to C2H2 yet. All right, so I have my grams of CaC2. I needed to convert it to moles, so I added up the molar mass. I put that on bottom so that grams will cancel. Remember, we don't want grams. We're trying to get to liters, so we need to get rid of grams. All right, so see, if you look now, I have moles of CaC2. So I've successfully converted to moles. So now we just move on. Okay, don't start a new problem, just keep going. All right, step 2 is mole ratio. So that's what we learned in the previous lesson video. All right, so remember, you pull the coefficients. So technically there's a 1 here, technically there's a 1 here. So some mole ratio, 1 mole equals 1 mole. All right, so 1 mole of CaC2 will produce 1 mole of C2H2. So how do I know which one goes on bottom? I follow the golden rule. If moles of CaC2 is on top, moles of CaC2 has to go on bottom. How many? 1 mole, because that is my coefficient. What does 1 mole of that equal? Well, it equals 1 mole of acetylene, because that is the coefficient. All right, so now if you look, moles of CaC2 cancel. And so now I have moles of C2H2. So see, now I've gotten rid of CaC2, so I'm getting closer to my answer, because remember, I want liters of C2H2. So I've made it to C2H2, now I just got to make it to liters. So step 3 is convert to unit asked for. Well, the unit they asked for was liters, so which one would I use to get to liters? Well, I would use 1 mole equals 22.4 liters. So again, don't start a new problem, just keep going. All right, so how do I know if the 1 mole or 22.4 liters goes on bottom? Well, I follow the golden rule. So moles of C2H2 is on top. So moles of C2H2 goes on bottom. How many? 1 mole equals how many liters? 22.4 liters. All right, and so then if you look, moles of C2H2 cancel. So I'm left with liters of C2H2, which is what I want, liters of acetylene. So once you get to the unit that you want, that's when you know you can stop the problem. So I'll put an equal sign. So again, how do you solve one of these big things? You do it like we did when we first learned converting. Multiply anything on top, so 5 times 22.4, and divide by anything on bottom. So divided by 64. All right, and so that gives you 1.75 liters of acetylene, C2H2. All right, so remember, number, unit, substance. I'm not going to forget, so you better not forget. All right, number, unit, substance. All right, so again, I'm just going to briefly go back over what we did. Now you can see the whole thing. So we start with what we're given, 5 grams of CaC2. First step was change that into moles. Because I had grams, I used molar mass to change to moles. I added up CaC2 just using the masses on the periodic table and got 64 grams equals 1 mole. I put the grams on bottom so it would cancel. Then I had moles of CaC2, so I moved over to step 2, mole ratio. So I put moles of CaC2 on bottom, so it would cancel how many? Well, I put 1 because of the coefficient, and that equaled 1 mole of my acetylene, my C2H2, which I also pulled from the coefficient. And then last step is convert to unit asked for. Well, I asked for liters. So I put my 1 mole of C2H2 on bottom because I wanted it to cancel. And 1 mole for liters equals 22.4 liters, which I put on top. Okay, so for these, I promise, you just need to see a couple. Like, I wouldn't even try the next one yourself at all. All right, I would wait a couple of times on this one. All right, so let's look at another one. So it says, how many molecules of oxygen, so I'm looking for molecules of oxygen, are produced by the decomposition of 6.54 grams of potassium chlorate. Now this is where you have to be careful. Which one of these is potassium chlorate? Some of y'all, you have trouble with naming from chapter 9. Okay, this one is potassium chloride. ClO3 is on your polyatomic ion sheet, it's chlorate. So this one is potassium chlorate. You have to make sure that you're starting at the right substance, otherwise you're going to get the wrong answer. All right, so we're going from here to here. So we're starting with grams. We are trying to get to molecules. All right, so remember, you start with what you're given. So I'm given 6.54 grams of potassium chlorate. All right, so first step, I need to convert to moles. So I have grams, so which one of these would I use to convert to moles? Well, 5 grams, I'm going to use molar mass. So I need to add up the molar mass. Now this is where I see some mistakes happen in class. So when you're adding up molar mass, you do not look at any coefficients. Don't worry about coefficients. Coefficients are only used in the mole ratio step. Okay, they're not used in any other step. All right, so we're going to look at the periodic table. K is 39, Cl is about 35, oxygen 16 times 3. Okay, so once you add all that up, you should get about 122 grams. So 122 grams equals 1 mole. So which part goes on bottom? Well, because I have grams on top, I want the 122 grams on bottom because I want that to cancel. And that, of course, equals 1 mole. Okay, so remember, the reason that I put the grams on bottom, there's like a mosquito flying around in here. You probably can't see it. But anyway, so I put the grams on bottom because oh gosh, this is awkward in the middle of a lesson video. I didn't even get it. So I put the grams on bottom so that it will cancel out. All right, so now I have changed it to moles of KClO3. So then I'll move on to step 2, which is mole ratio. All right, so 2 moles, that's my coefficient of KClO3, equals 3 moles of O2, or oxygen. So how do I know which one goes on bottom? I follow the golden rule. So see, y'all, if you'll write everything out like I do, you can always follow the golden rule and always know which part goes in the denominator and which part goes in the numerator. All right, so I have moles of KClO3 on top, so I'm going to put that on bottom. I'll look up here and say, okay, well, I'm going to use 2 moles, and then that equals 3 moles of oxygen. So see, now I have successfully gotten to the other substance. All right, so then I move on to step 3. It says convert to unit asked for. So in this case, the question has asked for molecules. So I'll look over here and say, okay, which one will get me to molecules? Well, molecules is Avogadro's number. That's where we do our representative particles. All right, so we know 1 mole is 6.02 times 10 to the 23 molecules. So how do I know what part goes on bottom? Golden rule. I have moles of O2 on top, so I'll put moles of O2 on bottom. How many? 1 mole. Remember, you only use coefficients in your mole ratio step. When you're using these conversion factors, these always equal 1 mole. All right, so 1 mole of O2 equals 6.02, pulling it from right here, 6.02 times 10 to the 23 molecules of O2. So see, moles cancel. I'm left with molecules of O2, which is what I want, so that means I'm done. And so then I just have to multiply and divide. So remember, you multiply any of the numbers on top divide by any number on bottom. Okay, don't multiply by those two just because you see the multiplication here. You're dividing by both numbers. So one thing you may want to do, so I get 4.84 times 10 to the 22. One thing you may want to do is, even though you're not ready to try one on your own just yet, maybe pause the video and get out a calculator just to make sure you can get that answer, just using my work. Okay, because if you can set it up but you can't put it in the calculator right, then you're going to have some trouble. Alright, so just make sure you can get that answer. Alright, so let's look at the next one. Okay, again, probably wouldn't try one just yet. Okay, maybe just watch me do this one again. So it says, how many grams of NH3, so we're looking for grams of NH3, are produced by the reaction of 5.4 grams of hydrogen. So we're going from here to here. So we're not worried about nitrogen. Alright, so we start with what we know. This is kind of low. I'm not sure if y'all can see that well, so what I'm going to do is I'm going to move this up here. So let me erase this one real quick. I want to make sure that y'all can see what I'm doing. So here, we'll just take this one and we'll go right up here. So we're doing this problem just in this area. Alright, so start with what we know. So we know we have 5.4 grams of hydrogen, which is H2. So I'll start with 5.4 grams of H2. Alright, so then I follow my steps. Step 1 is convert it to moles. Well, I gave you grams, so which one would we use? Molar mass again. So remember, molar mass, we just pull from the periodic table. So hydrogen is 1 times 2, so obviously 2 grams, equals 1 mole. How do I know which part goes on bottom? Well, I follow the golden rule. Grams of H2 must go on bottom, so we added that from the periodic table and got 2. What does molar mass always equal? It always equals 1 mole. Okay, so again, notice I did not use the coefficient when I added up my molar mass. Alright, so grams cancel, so we're left with moles of hydrogen. So then step 2 says do the mole ratio. So if you look down here, 3 moles of hydrogen makes 2 moles of ammonia, or NH3. So how do I know, does the 3 moles or 2 moles go on bottom? Well, I would look at my golden rule. Moles of hydrogen has to go on bottom, so it will cancel. So how many moles? Well, I'll look at my coefficient, 3 moles. And what does that equal? It equals 2 moles of NH3. So moles of H2 cancel. And so see, now I've gotten to NH3, so I'm getting closer. The only problem is I have moles, so I've just got to get to grams. Alright, so last step is convert to unit asked for. Well, I asked for grams, so what are you going to use? Well, when we use grams, we use molar mass. Now you may think, wait a minute, we just did molar mass. Well, we did molar mass for H2. Now we're talking about NH3, so we have a different molar mass to work with. Okay, so when you add up NH3 on the periodic table, N is 14, H is 1 times 3, so you're going to get 17 grams. So does 1 mole or 17 grams go on bottom? Well, we got to follow the golden rule. Moles of NH3 is on top, so 1 mole of NH3 goes on bottom, and that equals 17 grams of NH3. Okay, so see, some people get confused because notice on this step we had our molar mass on bottom, but that's because we had grams up here. On this step, we have molar mass on top, but that's because we have moles right here. Okay, so writing out number unit substance for every single step is a surefire way to just get everything right. Okay, please do not try to take shortcuts. Please. Alright, so now we got to grams of NH3, which is what we want. So last step is multiply and divide. So I would do 5.4 times 2 times 17, because those are all on top. And I would divide by 2 and 3, because those numbers are on bottom. And so when I do that, I ended up getting 30.6 grams of NH3. Alright, and so don't forget number unit substance. So remember, all of this goes with this question. I just didn't have enough room at the bottom here to do it all. Alright, so now we're getting to the point where you may want to try one on your own. And don't get discouraged if you don't get all the steps right on your very first one. You know, even if you only get 1 or 2 steps right, that's still some progress. These are long problems. And my numbers are slightly different because I round differently when I make my answers for my PowerPoints than I do when we do our answers in class. All right, so maybe try the top one, but maybe even still wait and just try this one. That would probably be the best thing because we still have section assessment where you can try some. Okay, so you can try this one if you're feeling confident, otherwise wait one more time. So it says how many molecules of oxygen, so we're looking for molecules, are required to burn 3.86 liters of carbon monoxide. So then again, you need to be careful. We have CO and we have CO2. CO2 is carbon dioxide because there's 2 oxygens. So this one is carbon monoxide because there's 1 oxygen. So we're doing 3.86 liters to molecules. All right, so remember, just start with what you're given. So we have 3.86 liters of carbon monoxide. So first step is to convert to moles. Well, we have liters, so which one would I use? Well, I would use the 1 mole equals 22.4 liters. How do I know what goes on bottom? Well, I follow my golden rule. Liters of carbon monoxide must go on bottom, so I'll put my 22.4 on bottom. 22.4 liters always equals 1 mole. Add STP, of course. So liters of carbon monoxide cancel. I'm going to try to start going a little bit faster so this video can end at some point. All right, so step 2 is mole ratio. So if you look, 2 moles of carbon monoxide equals 1 mole of oxygen. So again, follow the golden rule. Moles of carbon monoxide have to go on bottom. So how many? 2. What does that equal? It equals 1 mole of oxygen. So moles of carbon monoxide cancel out. So now move on to step 3, convert to unit asked for. Well, it asks for molecules. So I go over here and I say, well, which one would I use for molecules? I'm going to use Avogadro's number. I look at my golden rule. Moles of O2 must go on bottom. It is 1 mole. And that equals 6.02 times 10 to the 23 molecules. So my moles of oxygen cancel. I'm left with molecules of oxygen. And so then all I have left is multiply and divide. So I do 3.86 times 6.02 times 10 to the 23 and divide by 22.4 and 2. Remember, you just multiply across the top, divide across the bottom. That's all you have to do. All right, and so I got 5.19 times 10 to the 22 molecules of oxygen. So number, unit, substance. And y'all, the thing is, yes, these are taking me forever to show you. That's because I'm having to show you how to do every single step and explain to you why. Once you get good at these, you can do them pretty quickly. Okay, it's just a pattern that you follow. Okay, and sometimes you deviate from the pattern. Like if I gave you moles and asked you for molecules, you could skip step 1 and go directly to mole ratio. So, you know, it's just a pattern that you follow, and you just follow the golden rule. The sooner you understand the golden rule, the easier your life will be. All right, so maybe pause the video and try this one. Let's just see what happens. I'll assume you've done that, and we will do it together. So it says, how many grams of phosphorus trihydride? So trihydride just means 3 hydrogens, so we're looking at pH 3. So how many grams of phosphorus trihydride are formed when 0.42 liters of hydrogen reacts with phosphorus? So we're going from here to here. All right, so of course we start with what we know. So we know we have 0.42 liters of hydrogen. So first step is convert to moles. So I was given liters, so I'm going to use 22.4 to convert to moles. So 1 mole equals 22.4 liters. I'm going to follow the golden rule. So liters of hydrogen must go on bottom. So I'm going to put the 22.4 on bottom. 22.4 liters always equals 1 mole at STP. So my liters of hydrogen cancel. Alright, so I completed step 1. Step 2 is mole ratio. Well, if you look, 6 moles of hydrogen make 4 moles of pH 3. So I follow my golden rule. Moles of hydrogen must go on bottom. How many? 6, because that's the coefficient. Remember, mole ratio step is the only step we use the coefficients. 6 moles of hydrogen equals 4 moles of pH3. So moles of hydrogen cancel. All right, now I move on to step 3, convert to unit asked for. Well, it asked me for grams. So what do I use to get to grams? I use molar mass. So when you add up pH3, P on the periodic table is 31, H is 1 times 3, so that gives us 34. So do I put the mole or the grams on bottom? Well, let's look at our golden rule. Moles go on bottom. So remember, molar mass always equals 1 mole. We don't use the coefficient when we're dealing with molar mass or anything like that. So 1 mole of pH3 equals 34 grams. So moles of pH3 cancel. I'm left with grams of pH3. And so last step is multiply across the top. 0.42 times 4 times 34 divided by the bottom. So divided by 22.4 and divided by 6. So once you do that, you should get 0.425 grams of pH3. And that's it. All right, so hopefully, even if you didn't get the whole, well, hopefully you got the whole thing right, but if you didn't, hopefully you at least, got started on the right steps. A lot of people, for some reason, they hit a wall after step 2. I don't know why. They just can't get through that step 3 for some reason. All right, so see, these aren't that bad. I love these because I just think it's so logical. You just follow that golden rule and I don't know. I obviously have a math and science mind. If you have an English and social studies mind, you probably hate this and are just looking at the computer crying to yourself. All right, so let's look at our section assessment. So again, if you haven't tried one yet, the section assessment, I know it says 1 question, but we actually do 2 problems in it. So these are 2 more times for you to be able to try one on your own. All right, so it says the combustion of a settling gas is represented by the following equation. How many grams of CO2 and how many grams of water are produced when 52 grams of C2H2 burns? All right, so this is just 2 problems in one. We want to know how much CO2, but we also want to know how much H2O. So in other words, we're just going to do 2 problems. Okay, if you're getting a little confused, I'll just do the first one and then you can try the second one. So just pretend like it didn't ask me about water at all. Okay, we're just going to start from 52 grams of C2H2 and go to grams of CO2. Just pretend like water wasn't even discussed. All right, and then I'll let you try the one with water. All right, so we start with what we know, and that is 52 grams of C2H2. So first step is convert to moles. So I'll look over here. Which one am I going to use? Well, they gave me grams, so I'm going to use 1 mole equals molar mass. So I add up C2H2. C is 12 times 2, and H is 1 times 2, and so that gives us, let's see, what, 24, 26 grams. So because I have grams of C2H2 on top, I'm going to put grams of C2H2 on the bottom. So I'll put my 26 grams. Molar mass equals 1 mole every time. Remember, don't use coefficients yet. And don't use coefficients when you add up the molar mass. I cannot state that enough. All right, so next step is mole ratio. So this is where we're going to use our coefficients. So 2 moles of C2H2 equals 4 moles of CO2. So I'll look at my golden rule. Moles of C2H2 is going to go on bottom. And so I'll look at how many. It's going to be 2. And that's going to equal 4 moles of CO2. So moles of C2H2 cancel. So see, as I'm not explaining so much, we can go through these a little bit quicker. So I move to step 3, convert to unit asked for. Well, it asked me for grams of CO2. Remember, we're not focusing on water right now. It asked me for grams of CO2, so that means I'm going to need to use molar mass again. So 1 mole equals molar mass. Well, C is 12, O is 16 times 2, so that's going to be 44 grams in 1 mole. So I follow my golden rule. Mole of CO2 has to go on bottom. So remember, molar mass always equals 1 mole. So 1 mole of CO2 equals 44 grams of CO2. So moles of CO2 cancel. So I'm left with grams of CO2. So remember, all I do is multiply across the top, divide across the bottom. And so for that one, I ended up getting 176 grams of CO2. Okay, so now that I did that part, I want you to try the second part. So you're going to start with 52 grams of C2H2, but you're going to go to grams of water and figure out how much water we're going to make. All right, so I'm going to assume you paused the video and tried that one already, and so I'll show you how it goes. So you're going to start with 52 grams of C2H2. So first step is convert to moles. Well, since you have grams, you're going to use molar mass. Well, here's something convenient. We just added up the molar mass for C2H2. It's 26 grams. So grams of C2H2 goes on bottom, and it's 26. That's what we added up in the previous part. And remember, molar mass always equals 1 mole. We're not using coefficients on this step, only on mole ratio step. So grams of C2H2 cancel. So then we move on to step 2, mole ratio. So for your mole ratio, my mole ratio was 2 to 4, but your mole ratio is going to say 2 moles of C2H2 equals 2 moles of water, because you're going to water. All right, so how do I know what goes on bottom? I follow my golden rules. So moles of C2H2 must go on bottom. So I say how many? Well, it's 2, because the coefficient's 2. And it's going to make 2 moles of water. So 2 moles of H2O goes on top. So my moles of C2H2 cancel. All right, so last step is convert to unit asked for. So it asks for grams of water. So remember, for grams, I'm going to use molar mass again. But this time, I'm talking about moles of water, and I'm trying to get to grams of water. So I'm going to use the molar mass for water. So H is 1 times 2, and O is 16, so water is 18 grams. I'm going to put the mole on bottom, though, because of the golden rule. And how many moles? Well, remember, molar mass always equals 1 mole. And that's going to be 18 grams. That's just where I added up H2O off the periodic table. I did not use the coefficient. All right, so moles of H2O cancel. I'm left with grams of H2O, which is what the question has asked me for. So then I just multiply across the top, divide across the bottom. And so I ended up getting 36 grams of water. So if we did this reaction with 52 grams of C2H2 and enough oxygen, we're going to make 176 grams of carbon dioxide and 36 grams of water. All right, so this is very important too. If you cannot do, I just call this the normal 3-step stoichiometry problem. If you cannot do these, you do not need to move on to 12.3 lesson videos yet. Because if you can't do this, it's going to get really difficult really quickly for those. So if you need more practice on this before you move on, do that first. But hopefully, you're finding stoichiometry as awesome as I do.